This is the activity 2 of Foundations of Systems Engineering. Next. So, the Voler template can be used to specify user and developer requirements. Some sections of the model describe very detailed information about the system, while others are high level. This information can be used by developers and users. Talking about the IEEE 1362, um, the first specify user requirements, and the second, the IEEE 830, specify developer requirements. Both describe the current situation, justification, and description of the proposed system, and there is more one topic in the standard 830 that there is characteristics of software requirements. Next. Making a comparison between Voler and IEEE 1362, Voler addresses more about the description of stakeholders, functional requirements, non-functional requirements, and project issues, while the standard IEEE 1362 provides a more detailed descriptions of the current situation, justification for change, the proposed system, and a summary of possible impacts. Next. And making a comparison between Voler and IEEE 830, Voler has a more general character, while IEEE 830 has a more specific character. They have some similarities as the identification of the purpose, the restrictions, and about some attributes like security, maintainability, and portability. Next, Reinaldo is with you.
Okay. In general, a concept of operation is a user-oriented document that describes a system characteristics for the proposed system from the user's point of view. And the IEEE 1362 and IEEE 830 standards can be considered complementary and have some advantages and disadvantages. It's a first step towards a defined way of standardizing the process of contracting or purchasing products and services, even if virtual, such as software. This standard was defined through studies and conferences on the way that contracts were carried out. A ConOps can, even if broken, even if in a broken form, can mature with the system and be used across the acquisition life cycle of the project. Next, please. The Voler template advantage. It's the result of the development of the concepts started in 2009 in the applications and in the application of requirements engineering studies. It's a well-defined structure of how to develop the requirements of the project, result-oriented, and how to correctly define its special characteristics can be applied to a different process and systems, both in the physical and digital worlds. It's oriented from the point of view of the result and the client, and it has an area designed to consider the risks and costs involving in its structure. Next. In general, I didn't find anything wrong with the Volar template as a disadvantage. And okay, next.
So the second part of our activity this week was to read and understand the article Integration of Four-Phase KFD and TRIZ in Product Research and Development, focused on a case study about a notebook. The overall goal of the article was to use these tools to develop a notebook computer focusing on an environmentally friendly and energy efficient product. So for this goal, the quality function deployment was used. That is a technique that comes from production engineering in order to really connect users' needs with production, the product engineering. Next slide, please. So the goals when using this technique of KFD was to implement a product that would satisfy the customer needs, would fulfill the target specifications, also having also being in the cost objectives and considering more project managing specifications such as time-bound achievement and the profitability. So during the article, some contradictions were found while using the KFD methodology. So when combining KFD with TRIZ inventive principles, good decisions were made. So in the next slides, we're going to get more depth about this case study.
Okay, thank you, Lucas. So we have here the KFD combining with the TRIZ in complex product development. So it's very hard to translate the customer needs into quality characteristics when we are talking about complex product, for example, notebook. And the KFD, it helps to identify, to prioritize, and even correlate the needs with some proposed system features. For example, if you need some speed performance, you have to have a good memory and stuff to have a good processor performance. So, but sometimes, as told by Lucas, these needs are contradictory. For example, you need a high performance, but you need a high battery life as well. So this is a problem because when you have high performance, you consume more energy, and so you reduce the battery life. So this methodology, the TRIZ, it's a Russian methodology, helps to solve this contradiction in an innovative way. And the main purpose is to thinking outside the box. So you take this problem, this specific problem, for example, this mentioned before, the high performance in battery life. This is a contradiction. So you think outside the box. So you take this problem for a generic environment of problem. You not take this in a notebook problem. And so you can take different point of view, and it's easier to get an innovative solution. And so finally, you'll be able to define all your product subsystem by focusing on your customer.
With correlation between the quality function deployment and the TRIZ, regarding innovation products. First, the quality-oriented methodology of the QFD contributed to the desire to start from, while through the innovation-oriented methodology, the TRIZ, proposals and notions for innovative settings were reached. In practice, while the QFD methodology has the powerful conceptual appeal in the basis of analysis, the TRIZ method gives a more innovative thrust and deals the aspects that are strongly constructive. The matrix of contradiction has been used, and through it, it has been possible to rework the innovative problems suggested by the analysis of the QFD. It is clear how the two methodologies mentioned in this research paper can be integrated within a path of development of getting innovative products. Next, please. Harrison.
Can you see the next slides?
No, it's not moving, it looks like. Yeah, now I can see, thank you. In this study, it aimed to develop and market an environmentally friendly and energy-efficient notebook computers. While using the TRIZ in every phase of QFD, innovation and solving problem were achieved as follows. In the first phase of the quality function deployment, the LED white light bulbs were used rather than the CCFL for the backlight module illumination, which lead to a thinner and lighter design, lower power consumption, and improved environmental friendliness. Next, please. In the quality function deployment, the second phase, inspection of engineering diagrams indicated that the bottom cover and the PCBA were fit too closely together, which could result in a negative interaction effect in the form of cover wrapping. The bottom cover was also determined to offer poor dampening efficacy. Using the aluminum-magnesium alloy frame reinforces the structurally weaker areas of the plastic bottom cover and enhances the overall durability of the notebook. Next, please. In the third phase of the quality function deployment, the ICT mechanical interaction was substituted with boundary scan technology and the automated X-ray inspection system to improve the manufacturing process by reducing costs related to fixture making and remanufacturing. Next, please. In the fourth and last phase of the quality function deployment, the length of time taken by the equipment to stray from normal operating parameters rather than the length of time to break down should be used. So this will be better for preventive maintenance cycles. Irregular preemptive adjustment may be performed on equipment to help determine whether equipment has strayed from normal operating parameters or it is still working normally.